There are many ways of joining materials together. But take something as advanced as a modern aircraft and you'll find it's put together with thousands of nuts and bolts and other threaded fasteners. Why? Because these types of joints are efficient, they're extremely strong, and when it comes to service or repair, they can be easily disassembled. However, whatever the product, the degree to which such fastenings are tightened is critical. Too loose, and the nut may vibrate free. Too tight, and the bolt may break. In some circumstances, this may simply be inconvenient. In others, it can be a matter of life and death.
0, all engine running. Liftoff.
Correctly tightened fasteners will, on the other hand, function perfectly for years, helping to keep products safe and in service. This is why so many leading organizations worldwide recognize the value of correct torque. Torque is a twisting force. It's measured by multiplying the force on a lever by the distance from the point of application. We all know we can tighten a nut much more easily holding a wrench near its end. If we hold the wrench at its midpoint, we need to exert twice as much force to apply the same torque. Applied torque is a measure of the tightness of a nut and bolt, but it's not actually the torque that holds the parts together. In fact, the thread of the fastener converts rotary motion into an axial load that stretches the bolt, thereby converting torque into tension. This in turn creates a clamping force between the face on the nut and the head of the bolt, and it's this force that holds the joints together. The more the nut is turned, the greater the stretching of the bolt and the greater the clamping force. The effect this has will depend on the type of joint. Broadly speaking, joints are described as being hard or soft. A hard joint is usually one where a short bolt is used to clamp metallic, non-compressible elements. A soft joint, on the other hand, may incorporate plastic or gasket elements, which will be compressed and deformed during tightening. With a hard joint, the limiting tightening factor is likely to be the bolt. As the bolt is tightened, it will start to stretch in a reasonably uniform manner. However, as more torque is applied, the bolt will reach a point when it gives and starts to deform permanently. This is known as the yield point and marks the end of the elastic limit of the bolt. Further tightening will eventually cause it to break. The objective when assembling this kind of joint is to stretch the bolt to induce the correct clamping force and to maintain a reasonable safety margin away from the critical yield point. For most applications, the aim is to achieve a tension of around 70% of the yield strength of the bolt. People need to be able to measure torque, either to specify the correct value for assembly or to check the torque of a previously tightened bolt. There are 3 generally accepted methods of measuring the torque applied to a fastener. The decision on which to use will depend on the configuration of the particular joint under consideration. In the just move test, increasing torque is applied to the fastener that has already been tightened. A measurement of the torque that needs to be applied to make the nut just start to move gives an indication of the torque that was originally used to tighten the fastener. The loosening test is very similar, only this time the torque needed to break free the fastener is measured. Comparison between the value just measured and previously established break-free values again gives an indication of the correctness of tightening. In the third method, the marking method, a nut or bolt and its adjacent surface are marked. The fastener is undone. And then retightened at the point at which the marks realign. Measuring the torque used to achieve this can give a reliable guide to the original assembly torque. There are just 2 basic categories of torque tool, those that measure the torque being applied and those that signal when a preset torque has been reached. Measuring tools generally have a scale, dial or digital readout. The torque is measured continuously as it is applied. Measuring tools are ideal for use in research and development, inspection, quality control and servicing, where there is a need to check a variety of torque settings. These multifunctional tools are also used in assembly operations, where an operator may be required to tighten fasteners to various different torque values. Preset tools have to be set to the required torque on a calibrated torque tester, or in some cases on the calibrated scale on the tool itself. When the required torque value is achieved during the tightening, the tools either slip, break or click as a signal to the operator. This significantly reduces the possibility of over-tightening. These tools are ideal for production where the operator could be unskilled, but repeatable accuracy is required. The torqueleader dial measuring wrench is one of several tools commonly found in research and development departments for accurately measuring and applying torque. The wrench uses a finely tuned spring mounted between the two pivoting sections of the tool. As torque is applied, the spring compresses, and an overload protection stop prevents the user from damaging the mechanism by applying excessive force. The amount of movement is measured through a sturdy rack and pinion system, accurately converting linear motion into a reading on the dial of the wrench. Here, as well as the needle indicating the actual torque being applied, there is a maximum reading indicator, sometimes referred to as a slave pointer, which is moved up and then remains at the peak torque achieved. Some torqueleader dial measuring wrenches also have a light and bleeper to indicate when a specified torque has been achieved. A specific advantage of the principle employed in the design of the torqueleader dial measuring wrench is that it's not length dependent. It will measure the correct torque wherever it is held along its handle. For convenience of use, most torqueleader dial wrenches also incorporate a ratchet. Dial measuring screwdrivers measure torque through the use of the known twisting force needed to distort a metal torsion bar. The amount of torque applied is measured on a clearly marked dual-scale dial. This tool can be used in two ways. It can either be set in track mode, so that it consistently tracks the applied torque, or it can be set in memory mode, which is enabled by withdrawing the slider and resetting the bezel ring to 0 before use. This tracks the applied torque as before, but then leaves the memory pointer at the maximum torque position. In production environments, the need is for tools that can apply the correct specified torque consistently, easily, and repeatedly. Often, rather than having a tool which measures the torque being applied, it's better to have a tool which simply applies the preset torque value. Unlike torque measuring tools, it's not necessary to have a dial or readout. With torqueleader, this is achieved through a range of tools which allows the user to apply torque right up to the preset value and then slip or break through a positive angle, making it impossible to over-tighten. There are three main types of presettable torque tool. With click tools, there is an audible click and the operator will feel an impulse when the preset torque is achieved. As force is applied to the tool, the torque will increase. At the preset torque value, the tool will click and there will be approximately 3 degrees of tool movement. Resetting takes place when the hand pressure is released. However, if the force continues to be applied, then the fastener will be over-tightened. Braking torque tools brake in a controlled manner at a point along the tool's length at the preset torque. As force is applied, the torque will again increase. At the preset torque value, the tool will brake through an angle of 20 degrees to signal that the correct torque has been applied. Again, the tool will automatically reset when the hand pressure is released. Continued application of force beyond the 20-degree movement can again lead to over-tightening. However, the greater tool movement makes this significantly less likely. With slipping tools, torque again increases with the applied force. At the preset torque value, the mechanism in the tool causes the application of torque to cease, and the tool slips free for a short time until it automatically resets. Even if the application of force is repeated, the preset torque will not be exceeded, therefore making it impossible to over-tighten the fastener. With the torque safe slipper wrench, a roller is pushed by a spring against a multi-lobed cam. Until the specified torque is achieved, the roller transfers the driving force to the cam. At a preset level, however, the force of the spring is overcome, and the roller travels over to the next position on the cam. As this slipping action will repeat at each subsequent cam position, excessive torque can never be applied. All torqueleader production wrenches incorporate a unique double positive locking system. To adjust the tool, the handle end cap is removed and the locking mechanism is released using a hexagon key. The tool is then adjusted using a specially designed adjusting key that significantly reduces the possibility of unauthorized adjustment. Finally, the tool is relocked using the hexagon key and the cap replaced, leaving the wrench ready for use. The TSP TorqueSafe slipping wrench is also fitted with the double positive locking system, while the TSC slipping wrench incorporates a calibrated scale for ease of adjustment. Torqueleader production tools come in many forms and variations, because every production environment has its own very specific requirements. For applying torque values in assembly operations that are safety critical, the torque safe slipper and torque breaker wrenches can be adapted to pass an electrical signal to a process controller or similar device at the point of correct torquing. The length of signal can be varied using a torqueleader signal delay unit to match the input requirements of the process controller. Only then will the controller allow the operator to move on to the next assembly stage. This signaling option can be incorporated into other torqueleader production tools. In response to customer demand, this signaling system has been enhanced by the introduction of TAMS, the Torque-Activated AM Signal System. A miniature radio transmitter generates a signal every time the tool operates. Up to 4 TSN or TBN wrenches can be used simultaneously with each receiver unit. All transmitters have their own unique transmission signature. The battery condition in the transmitter is continuously monitored by the receiver unit. The receiver counts at 2 levels. The shift count gives the number of tool operations in a given period or working shift. The background count gives the number of tool operations since the system was set up. This is a useful means of monitoring tool servicing or recalibration periods. The output relay times can also be adjusted between 1/4 of a second and 2 seconds, or can be disabled completely. For the application of lower torque values, a similar system to the TSN mechanism, using a large ball and 3 smaller ones pressed against a radial cam in the handle, is used in torqueleaders' torque-limiting screwdrivers. The torque setting is adjusted by altering the compression of the spring. Again, the setting mechanism is protected by a dust cap to prevent unauthorized adjustment. With the quickset version of the torque-limiting screwdriver, however, the operator is able to set the required torque value by adjusting the micrometer-calibrated scale. In its quest for product improvement, MHH has introduced a modified version of the quickset and quickset minor screwdrivers, incorporating an ergonomically designed molded rubber handle, an improved positive lock adjustment system, and a new design of bit holder. As quality control becomes increasingly critical in all areas of production and servicing, more and more companies are setting up their own in-house calibration departments. Here, torque tools of all kinds are inspected on a regular basis and calibrated using accurate calibration devices. Torqueleader provide for this purpose a full range of torque calibration analyzers. The ETCA Electronic Torque Calibration Analyzer has been introduced for the checking and calibration of both hand tools and small power tools up to 30 Newton meters in capacity. The ETCA has been designed in two parts. The display electronics can be separated from the torque transducer. This allows interchangeability to meet every customer need. The unit is available both mains-powered and with an internal battery option. Torque data can be downloaded to a computer using an RS-232 interface. The most unique feature of this instrument is a slip-free overload protection system. If the transducer is accidentally overloaded, here being done deliberately, a clutch slips free before any damage can occur. Using the two adjusting keys provided, the unit can easily be reset, ready for further use. The ETCA, with 12 pre-selectable languages, can monitor both peak and first peak torque values and can be used in manual or automatic reset modes. A run-down fixture is supplied to enable the ETCA to measure the torque output from power tools. A range of springs and spacers enable the fixture to simulate hard and soft joints. The ISO 1000 test rig has been designed to verify the accuracy of torque wrenches to the stringent requirements of ISO 6789, the international standard for torque tools. Here we see the test rig in use with the XTM200 portable torque calibration analyzer. In addition to its complete range of standard products, torqueleader tools can be modified for specific applications. In any industry where screw-top containers are used, for instance in pharmaceuticals and with perfumes, the tightness of the bottle or jar caps can be of vital importance. Torqueleader manufacture a range of closure meters to enable quality checks to be performed. The meters can be used for a combination of just move and loosening tests to confirm the degree of sealing achieved. It's difficult to imagine a task more safety critical than that of servicing aircraft. The correct application of torque is just as important here as it was in the aircraft's original manufacture, and perhaps more so. British Airways use a whole range of torque-leader tools in the regular maintenance and repair of their fleet. These include torque-limiting screwdrivers that have been specially adapted into a brace handle for rapid yet precise use. The automobile industry provides another demanding production environment. Special spanner attachments can be designed where there are access restrictions that preclude the use of conventional end fittings. In this heavy engineering environment, tools need to be robust, hence the use of the TSN torque slipping wrench with its stainless steel head for torquing the component pallets of this advanced machining centre. This tool has been supplied in a specially modified form, without the fine-toothed ratchet, so that the operator can undo bolts as well as doing them up. Here, a torque-leader braking wrench has been adapted with a strap attachment to allow the consistent torquing of a life jacket inflation cylinder. As a company, MHH Engineering, the manufacturer of the torque-leader range, offers over 50 years' experience in the production of tools. The company, a leading UK manufacturer of torque control equipment, is an autonomous member of the Gador Group, one of the world's leading manufacturers of precision tools. Torque-leader tools are sold worldwide in a wide range of industrial sectors where the product's reputation for quality, reliability and durability is recognised and appreciated. Over 70% of the torque tools manufactured are exported. MHH Engineering was the first torque tool manufacturer to attain ISO 9002 Quality Assurance certification. The MHH Calibration Laboratory is accredited by UCAS, the United Kingdom Accreditation Service. Working to these demanding standards, MHH apply the same care and attention to every stage in the production process. Torque-leader tools are manufactured using the most advanced equipment and are then assembled by hand, ensuring that the end product is rugged and maintains its accuracy throughout its working life. All torqueleader tools conform to the international standard ISO 6789. To conform to this standard, each tool has a unique serial number stamped or laser engraved on it, matching the number on its certificate of calibration to ensure complete traceability. The test results are recorded on computer and printed onto each individual tool's test certificate. Details of the test equipment used for the calibration are also specified on the certificate. With accuracy and reliability of paramount importance, torqueleader products are designed and manufactured for long life. The company's engineers work closely with their customers to provide the most effective design solution to any torque control problem. In some cases, the solution may involve supplying existing tools. In others, the company's in-house design department will create a tool or kit of tools specially for the job. With this combination of careful evaluation, good design, production, quality control and after-sales care, torqueleader tools will continue to be the first choice for companies around the world. Now we look at how torqueleader tools are used by major manufacturers and maintainers to ensure that their products are assembled to the required specification and are kept in that condition. Typically, there are 5 key areas in which the measurement and application of torque is important: research and development, production, quality control, service and repair, and in-house calibration. HMS Sultan has the worldwide responsibility of ensuring that all life jacket maintainers throughout the British services are trained correctly, and the UK Ministry of Defence chose MHH Engineering to design a kit of tools for this vital requirement. Petty Officer Keith Spiller addresses a course of mixed services personnel on the importance of torque in the servicing procedure.
Put your little finger in and pull it. The last torque loading we've got to do with this particular life jacket is the nitrogen cylinder. Now in the past we used to do it hand tight. Like I said, everybody's got their own version of hand tight, alright? Because we used to run the risk of the cylinder going off if we put it in too hard, we used to have girlies on the course that would just sort of like screw it in and pinch it down. What that leads to is a partial inflation. A partial inflation is more dangerous than no inflation whatsoever. Alright, because if a guy's unconscious and he's got a half inflated life jacket and he rolls onto his front, the gas in the jacket is then pushed to the neck and it physically holds his head under the water. And what we need to use is this strap wrench. Now this is preset at 35 £1/4 inch, alright? And it's very, very simple to use. All we do is bring it over, and what we're trying to achieve at this point is that we're getting a square face between the torque wrench and the cylinder, alright? Once it's on, just support the strap, support the head, and all we do is we turn. And eventually it just breaks. Alright? That's it.
Here we see the toolkit in operational use on the aircraft carrier HMS Illustrious. The kit includes a minor screwdriver for the correct insertion of Schrader valves, a TSN25 slipping wrench to tighten the retaining nut for the firing mechanism, and a modified TBN20 with a strap attachment to facilitate the correct tightening of the nitrogen inflation cylinder.
The life jacket maintenance, one of the most important things we've got to deal with is the operation of it. Therefore, if it doesn't operate correctly, it won't do the job it's supposed to do, i.e. save the life of the person wearing it. So one of our most important factors with maintenance is the actual setup of the operating head and the fitting of the inflation equipment. everybody's got a different right arm, so everybody will apply a different pressure. So by standardising that, what we're doing is minimising damage to the equipment, therefore we're increasing the life of the equipment. And two, what we're doing is we're guaranteeing to the end user that the equipment will work as advertised, so that if he has to go in the water or he goes in by accident, what he's wearing will save his life. At the end of the day, by applying torque to the equipment, we're guaranteeing lives, we're saving lives, but in today's technology and economy, we're also saving money.
Aston Martin, manufacturers of the legendary range of sports cars, use torqueleader tools throughout the assembly of the DB7. A quickset screwdriver is used to tighten hose clips. Over-tighten and the hose will split. Under-tighten and coolant will leak. Here, a TSC with its adjustable calibrated scale is used to tighten bolts on the front upper crossmember of the vehicle's monocoque construction. From low-volume specialist vehicle production to volume assembly at IBC Vehicles. IBC, part of the General Motors Group, manufacture the rugged Vauxhall Frontera. A TSN 25 TAMS tool is used to apply and verify the correct torquing of the critical front brake caliper banjo bolt. In other assembly operations, we see the TSN 55 being used to tighten the front universal steering joint and on the rear stabilizer. And a TBN 55 braking wrench is used to confirm the tightness of critical brake pipe nuts. Regular audit checks are carried out on engine assembly using a BDS dial measuring wrench. A TBN 20 with a specially designed end fitting is used because of restricted working space. In this case, it ensures the correct tightness of electrical connectors in the area under the steering wheel. The De La Rue Company is world-renowned for their production of many countries' banknotes. They also produce many associated products, including banknote counting machines. A range of torqueleader products are used in the assembly of the equipment, and it will be appreciated that accuracy and reliability are of paramount importance when handling cash in any form. Here, a preset minor screwdriver is being used to torque down a timing printed circuit board mounted on a rotating shaft assembly. Standard screwdrivers are used to tighten the locking nut that retains a drive wheel. Torqueleader tools are also widely used in quality control. Here, a TT100 dial measuring screwdriver is used to ensure that the correct torque has been applied to main assembly fixtures. De La Rue also used the ETCA electronic torque calibration analyzer with its run-down joint simulator to check the calibration of electric screwdrivers. Conveniently, the ETCAs are mounted on a trolley, enabling trackside monitoring of the assembly tools, thus saving the time that would be incurred by returning them to the quality control department. A quite different production environment is to be found at IBM. In this high-tech cleanroom, hard disk drives are precisely assembled in clinical, dust-free conditions. Torque-limiting screwdrivers ensure that the drives are put together to the finest of tolerances. Colour-coded screwdriver handles make it easy for the operator to select the correct tool for the job, ensuring the right torque is applied to each screw. There are many applications for torque tools at a busy airport. Here at Southampton International Airport we can see a range of torque leader tools in action. The airport fire station uses the DDS 800S to check and tighten wheel nuts on their fire tenders. This check is part of a regular maintenance schedule that ensures that the tenders are always in a state of complete readiness should an emergency incident occur. British Regional Airways use several different torque leader tools in their maintenance and overhaul operations. A TBN 55 with a ratchet head is used for rapid rundown on terminal blocks in the engines of this Embraer ERJ 145 short-haul jet. The easily resettable quickset screwdriver is used to check the tightness of a range of retaining screws on the aircraft cockpit's navigation equipment. Osprey Aviation service and maintain executive jets and other light aircraft. A BDS dial measuring wrench is seen here checking the propeller retaining bolts on a Jetstream 32 aircraft. Minor torque screwdrivers are used to ensure the correct tightness of cable retention clamps on the propeller assembly. Similarly, the preset standard screwdriver is used on the cable retention clamps in the engine compartment. British Airways use kits of torque leader tools in the regular maintenance and repair of their aircraft. The TSN-55 is used here to tighten the outer casing on a Boeing 757 aircraft engine. While the BDS dial wrench checks the critical tightness of fasteners on the aircraft's hydraulic system. DDS and EDS wrenches are widely used in the airline industry to tighten and check wheel nuts and undercarriage fixtures. We've illustrated just some of the applications of Torque Leader's range of tools. They're used in the manufacture of many other products, as diverse as household items like vacuum cleaners and refrigerators, for telecommunications equipment and mobile telephones, and specialist medical tools used in surgery and dentistry. MHH Torque Leader offer a complete package: the tools, the support, and the advice. Using Torque Leader tools will ensure the reliability and safety of products, and the confidence of users and customers.
All engine running. Liftoff. We have a liftoff.